Welcome to the Muxall Open IoT channel. I am your host, Michael Klein. Please excuse the haircut. We're in pandemic day, 30 plus. My barber shop has been closed for a while. And so, here pretty quick, I'm going to start looking like I have hair like Einstein. I just wish I had his brains. Anyway, enough about my hair. So today we're going to be looking at a couple unknown thermistors. One of them, Joe, one of the beta testers, sent in. And another one I bought off the internet, and it looks pretty good. I'll show some pictures later. I already had set this up, and then it dawned on me I should show you pictures. The two unknown thermistors look identical. And that's what's interesting about them. But let me show you the test setup here real quick. So first we're using the purple Muxall Pro BBQ Controller. And in port 1 right here, we have got a PT100 RTD 3-wire. And I've had this thing for a long time. And this one, in port 3 right here, we have a 4-wire prototype PT100 RTD from one of our China manufacturers, okay? And then this ohm meter, my Fluke 875, that's measuring the ohms, and the thermistors right now is measuring the one I bought off the internet. I forget, they're a knockoff or something, I don't remember, but they're fairly unknown. So, and let me give you and this right here is my thermal cup, okay? And it just has ice in it with some water, and then later we'll stick them in this this thermos that has, it used to have hot water in it. It might not be hot by now, but it doesn't matter. We just need 3 data points. So we're going to get a hot, a cold, and then one somewhere in the middle, right? Okay, it's in the cold side. Both these probes in the water. Oh, and the probes are, of course, sticking in the water. Both the probe, my baseline probes, if you will, are reading around 32 degrees. This one's at, here, let me just zoom in. I'll be right back. Okie dokie, so we're zoomed in now. And as you can see, probe 1 here is the 3-wire, probe 3 is the 4-wire. And they're both reading pretty close, 32.0 and 32.7. And we're not going to use the 4-wire right now. I haven't verified its accuracy. I just thought I'd plug it in and see what it looks like. But yeah, the 3-wire is showing right down there at 32 degrees, which is probably pretty close to where it needs to be since it's sitting in ice water. So I'm just going to make a note. I don't know if you can see right here, but I'm just going to write down the temperature, which is showing 31.8 now. And but this right here is holding steady at 326.3 K. So I'm going to write 326.3. K at we'll just call it an even 32. Yeah, that's kind of bouncing around 32 F. Okay. I moved the Fluke probes over to the for the probe that Joe sent in, and it's different. So even though these probes look identical, you can see that it is definitely not anywhere near 326.3 K ohms, right? So this one is 158.9 K, and this thing's reading 31.7. Well, it's jumping around, so we'll just call it even 32 again. It's holding steady, or it's not holding steady, but it's sitting there around 32. It's interesting, this 4-wire one is actually pretty steady. It's just sitting there. It's kind of going down a little bit, but I don't know if it's from me moving the table around or what it is. but it's kind of sitting around 32.5, so we're just going to call it 32 for our thermistors. Okay, so that's Joe's, and this is the unknown. All right. Okay, so the next thing we want to do is we want to go to about the medium range. So I'm going to go ahead and pull our probes out, set them down, go ahead and get rid of our water. Okay, that's done. Go ahead and put some, this water's should be fairly close to room temperature. It's showing about 83 degrees in here. That's probably a little bit high because the temperature sensor is on the PCB, so it's going to pick up heat from the electronics. We'll go ahead and throw these guys in here, and these things don't have to be. We're not trying to get absolute zero or any kind of special temperature. We just need 3 data points, and it's best to have them kind of spread apart, right? You don't want them, we're close to each other, because when we get on the computer, you'll see we're trying to plot a curve. Kind of looks like this. I guess that'd be, what is that, logarithmic, right? Yeah, because exponential go up the other way. So it's going to come down, and so we just need to get 3 good data points for the calculator, and so it can give us a curve, and we can get our Steinhardt coefficients out of it, right? And we'll talk about that here in a minute. So I'm going to go ahead and pause the video. I'm going to let these things need to settle a little bit. Okay, so we're back, and it's been sitting there for, I don't know, 5-10 minutes, I guess. Everything seems to be settled down. We're reading about 70.8 degrees on the 3-wire and 72 on the 4-wire, which is kind of interesting. I don't know, you get about 71, I don't know, they're about a degree difference there. Like I said, I'm not really sure what the difference is. We're just going to split it down the middle, and we're going to call it 71. And the one that in Joe's, I looked it up. It's an Inkbird, and Inkbird thermistor for his monitoring station, and so it's reading at 56.92 K. At we'll just call it 71. 71, that's Joe's. And let's switch over to this other guy here. And he's reading about 114.6 K at 71. Okay. This is the unknown. I did look that up too. It's a replacement for. Sorry, I'm suffering from CRS right now. I just looked it up, and I'll have to tell you in a minute. Okay, so I looked up the what the unknown was, and it's a replacement for a Thermo-Pro, and I'll put a picture of it in the video, so you can see what it is. It was like $18 for 2 of them. A tad expensive, but seemed to be pretty good. I thought they were supposed to be I mean, they look identical to the Inkbirds, and I thought it was supposed to be a replacement for it. But as you can tell from the readings, even though they look identical, they're completely different. So if you bought one of those things, plugged it into your device thinking it's going to work, Inkbird or Thermo-Pro, it's not interchangeable. And this is why we have to make these custom curves for all these different thermistors, right? The RTDs are simple. It's a PT100, a PT1000. They have other ones out there, but those are the 2 main ones, all right? Okay, so next is the heat, and I'm just going to go ahead and And just pop these guys in here. I don't want to get them wet. Okay. And we'll go ahead and just let those sit. Whoops. Uh-oh. That's probably not good. Anyway. Yeah, I'll be back in a minute as soon as I think I just got that 4-wire prototype wet. So it might not be too happy here in a minute. Okay, so I've kind of let them settle down, and as you can see, both the 3-wire and 4-wire are rating almost identical. In fact, they are identical, 152.8, 152.8. Geez, you can't get any better than that. So, excellent. As you can see, we're on the, what are we on? Oh, we're on the Thermo Pro knockoff. So we'll just go ahead and write that down. So it's 18.51 K ohms at 152. Let's call it 152. I'll call it 153. It's kind of like 152.9, 152.9. Okay. And that's the unknown. I've been writing down. Sorry, you probably can't see what I'm doing. And then we'll go ahead and move this over to the Inkbird. And I don't know, this should be a authentic Inkbird because Joe sent it to me. He owns the Inkbird, and I'm guessing it's the real McCoy. There we go. Alrighty. So we've got 9.21 K ohms, 9.21 K at, and we'll just, it's in between. We'll still just call it 153. It's close enough for government work. And this is the, we're calling it Joe. Sorry, you can't see what I'm doing. I'm writing it down. Yeah, this is very professional. But it's okay. It will be very accurate. Because I've done this before, and they come out very good. Thermistors work really well. And that's probably why, and one of the reasons why a lot of people like them is because they're real high resistance, and so they don't use a lot of energy in battery operated devices, right? So excellent. That's our 3 data points. We've got 1, 2, 3 unknown data points, and 1, 2, 3 Joe data points, or Inkbird and Thermo Pro, right? So yeah, let's go to the computer. These are the Thermo Pro. I think they're knockoffs. I doubt these are from Thermo Pro. You can read through here if you want. And then Joe sent me a picture. Here's his Inkbird probes, and as you can see, they look pretty much the same. I mean, really, even the tips. Look, see how the tip right here is kind of tapered, and the tips on these things are, see how they're tapered? So, yeah, the only difference is these have a little ridge carved into the handle, and these don't. So, and I wouldn't call it a ridge. That's probably more of a gap. A ridge would be poking out, wouldn't it? So enough about that. Let's get to our thermistor calculator, shall we? All right. So this is from the Stanford Research Systems Inc. I have no idea if they're related to Stanford or not. Maybe not. I don't know. Anyway, this thing works pretty good, and what we're trying to get are these coefficients right here. So yeah, let's go ahead and we'll start plugging in some numbers. And if you're looking for me to explain this, I'm not going to try. I mean, it's just a math. They're just curve fitting these numbers in here, and popping out these coefficients that we're going to plug into our program here in just a minute. I don't know if I'll go through plugging them into the program, but I'll kind of show you the code a little bit just so you see what's going on. But anyway, enough of the blabber. I'm going to kind of follow. So I'm going to put the high resistance guy up here, which I believe, if I remember correctly, is the lowest temperature. So as you can see on the bottom right here, temperature, so temperature is going up, so it's the highest resistance, and then it's going to swing down to the higher temperatures. So, okay, so our first one, we're going to do the unknown one first, since it's first on my list. It was 326, 3 K. So it's 326.3 Ks, which is going to be 326.312. All right. So 326, the point would be right there. 0.3 K. So 1, 2, 3. Yeah. Yeah. All right. Whoa. The second one is, I should probably take a picture and put this up there, but I'm not going to. The second one, I need to put the temperature, and that was at 32. Oh, they want it in Celsius. Hold on, I got to convert this stuff. Okay, so I went ahead and wrote everything down and converted everything. So, okay, so we already entered this 326, 300. 326K, 300. I think that's right. Let me know if I make a mistake. And that's at 0C, right? Okay, and then R2 is 114.6. Okay. And I'll just copy and paste that in here. And that was at 21.7 C. 0.7. Whoops. 0.1. Oop. All right. And the last one is 18.5 K. And that was at 67.2. All right. Well, look at that. That looks pretty nice. Okay. So now that I have my curve, my coefficients, you can see our 3 data points right here. So what you have to do, and I don't really know if anyone's going to be interested in this part of it. If you are, leave a comment and I can show going through it. But only people are going to be really interested are the people that's developing on the LTC 2984 chip or 2986 or 2983 or what have you. So our goal is we need to get it into this form right here. This is for the camshaft, right? The camshaft. And this takes a little tinkering to get it right. And the reason why is because LTC, bless their hearts, has this beautiful little configurator right here. As you can see, I've been plugging in thermistor custom Steinhardt equations coefficients. And so you have to kind of go in here and by the way, if you've never seen this thing is hats off to these guys. I mean, this is beautiful. You can configure it so when I was first setting this thing up and trying to figure out how to code everything. And by the way, the libraries are open source. They're on our GitHub page. So if you want to go get them and you're watching this and you're developing this chip. Anyway, you can just go and say create C code and it downloads it. It downloads exactly what you need to configure the chip with based on your configuration, right? But I digress. Get back to the point. Okay, so you go into here and then you have your custom values right here. There's 6 values, and this one's got negative values in there. Not exactly sure what that is, but anyway, and I shouldn't say I'm not exactly sure. All it's doing is curve fitting this curve right here. And by the way, this is a beautiful curve. I mean, usually if you get errors, it's kind of like all over the place, right? you know, it's not exactly lined up with each other. And I could plug in some other coefficients and show you, and we might see it on Joe's. We'll do that in a second. But back to what we're doing here. So come in here, and then you have to convert all these. Whoop, there we go. You have to convert. So this is 0.717811 blah 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 times e to the -3, and you got to convert that over to, and e is not the natural logarithm, it's just exponent. And you got to start, I believe it starts from the 0 point, and it's kind of just the way we set it up right here. So you plug this number in here, and then this number in here, and this number in here. And as you can see, the zeros are going to get longer. This is a bad example. Let me look at one of these other ones. Oh, that one's even worse. There's nothing in that. Let's see. What does this one look like? Oop. Wow, all these are zeroed out. Anyway. Well, so yeah, I was probably messing around with it, just generating some coefficients. Actually, we could look at the code. Is there, I don't see any negatives here. Oh, it looks like maybe these guys. Oh yeah, so here's the negatives. Yeah, so here's another thing too, right? You know, so you have to convert the negatives, or anyway, you have to I'm not going to go into the whole programming aspect of it, but yeah, as you can see, this negative number right here is not quite what we need right here, and maybe that's why I thought this worked though. Anyway, I'm I'm getting off base here. But yeah, back to what I was talking about. So anyway, you got to plug these numbers in. I'm not exactly sure what I did right here. Is probably make the curve fit better. And so it takes a little tinkering is what I'm getting to. And so that's what we're going to get to with these numbers right here. So you got times 10 to the -3, -4, -7. If you look at this is, you know, probably the same thing. 0, 0, 0 point is times 10 to the -3. Yep, times the -4. So it's going to be very similar to this Camp Chef one, just with some different numbers in it, right? And as you can tell, looking at these guys, you're probably scratching your head going, what the? Actually, this one looks okay. I mean, this 9, anyway, it looks similar, but you're probably looking at this going, what? So, and I don't want to get into that. That's why we use this calculator. You can look in the data sheet. It has, they can only fit so many characters, so they're, anyway, let's not get into that. I'm just going to probably confuse everything. Yeah, so this is basically it right here. And then you plug it into this guy using this tool right here, convert it, and it spits out a bunch of these numbers right here. Right. This is probably the easiest way to say that. And then you just plug this into your code right here, and then in the GUI, you go to the config. This thing's probably not going to work. Oh yeah, I've turned the controller off. That's what I was saying. And then I just add thermistor, and then here's the different choices, right? And so that's it. Okay, so just real quick on. Well, hold on for a sec. Let's go ahead and do Joe's real quick. Let me close this stuff out. We don't want any of this stuff. This video is about how to calculate these Steinhardt coefficients, no matter what chip you use. This is just how it's done. You're probably not really interested in the details. I'm going to go ahead and save these numbers off right here. Excellent. So yeah, let's go ahead and plug these other ones in. So we got 158,900 at 0 degrees C. And we've got 56,920 at 21.7. And we've got 9110 at 67. Well, there you go. So you can see right here, this is a little bit off right there. It looks pretty good though still. Yeah, there you go. So all we have to do now is just put these numbers back in there. I'll save you the pain of watching me do that again. and that's it basically. So our thermistor, and we've got our Steinhardt model coefficients out of it. So now we can plug it into our LTC calculator and calculate those bizarre numbers it comes up with to fit all these crazy numbers into the chip. Right? And out pops what you really care about, and that being able to plug in your Inkbird or ThermoPro and make it work. So that's it. I hope you enjoyed that video. Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button, that really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.